ML kind of works better if people think like owners, end-to-end thinking, which is hugely powerful and underappreciated in the world right now.
How do you introduce culture change within an organization? What are you measuring? You're going to get what you measure, right? How do you actually make sure that people are rewarded?
Be aware of what goes into the model. Don't treat them like black box and go a little bit more and understand them.
Okay, let's get started. Hello, everyone. Welcome to another month of book club chat. This month, our book club is reading the book Reliable Machine Learning, and we're very grateful to have the book authors here. We have Cathy, Kranti, and Niall. For anyone who joined us today, please feel free to ask questions directly in the Zoom or ask in the chat. Thank you so much, everyone, for joining. Let's start with a round of introductions. My name is Sophia Yang. I am a data scientist in Anaconda, and I run this book club. Who wants to go next?
I can do it. My name is Sophia. Hi, everyone. I'm actually a software engineer here at Anaconda, and before that, I was in the oil and gas industry doing kind of like data science, a lot of that, and applications for oil and gas. So.
Okay, yeah. My name is Daniel Tost. I am an engineering manager. I've been working with data for the last 1.5 years, so I'm still learning a lot. And yeah, thanks for so much knowledge. I'm very grateful to be here today.
My name is Cathy Chen. I work at Google. I project managed the book and wrote a couple of chapters about organizational development. I'm an engineer and program manager, but I also have a degree in organizational psychology.
I can go next. Hi, I'm Kranti Parisa. I lead the product engineering at Dialpad. Before Dialpad, I was at Apple, ran search and personalization teams. So been in machine learning, search, information retrieval at scale for the last like maybe 10, 12 years. Yeah, pleasure to be on the team for writing the book.
Hi, I suppose there isn't anyone else left, so that's where we are. My name is Niall Murphy. I am currently CEO of a teeny tiny startup in the SRE and machine learning space. Prior to that, I was at Amazon, Google, and Microsoft for about 17 years, all told, during which I wrote and published the Site Reliability Engineering book, which sold 250,000 copies worldwide and ignited the SRE industry kind of ish. And most of my time that I spent doing ML was in the Google context, where I worked a lot with Todd Underwood and the ads teams in Google in Pittsburgh and Dublin and elsewhere.
Awesome. Thank you. Thank you so much for the introduction. So I'll start with a question, and then everyone else can also jump in. What is the story of the book? Like, how did you come up with this idea, and how do you put the team together? I know there are 5 authors. How do you come up?
Yep, it's a good story. Cathy, I'm just going to read your chat there. Niall, yes. There's a couple of different ways of telling this story, but Todd and I were basically always going to write a book, and we kicked around a couple of different ideas about what to write it on. And one of them actually, as you say, a degree in organizational studies, Cathy, one of them was on organizational kind of patterns in enterprises related to operations and so on. Anyway, eventually we ended up settling on machine learning, or attempting essentially to codify the knowledge that in particular Todd had developed over the past decade and a half, more or less, of running ML systems at scale in Google. And we knew that we wouldn't be able to do it ourselves because, like, there's just too much. As you know, the book is very dense, and I personally feel that actually it only covers some of those areas in an incredibly shallow way. Like you could expand the book into kind of 12 books of other things you would need to cover in detail, etc. But we looked for folks who could help us, and that's where Cathy and Kranti and Dee Scully, that's how they got involved. And the publisher was more or less always going to be O'Reilly, because O'Reilly have done all of my previous books. So that's kind of where it came from. We're basically trying to look for that place in the market where you need to know about how to do ML, but actually the details of model construction are less important than the totality of the organizational and team-based and product-based and architecture and so on. And these things are surprisingly under-discussed in most of the books that you see otherwise. Like a lot of those books are really strongly focused on models or model construction and data analysis, sometimes even secondarily. But basically the book about the other things you don't typically find books about, I suppose.
That's exactly my next question. What's special about this book? I think you just answered that question very well.
I just want to add like a couple more thoughts there. So when we started, thinking about what do we want to cover, right? So as Niall said, we contemplated about like various aspects of it, but one thing that we saw the gap is the comprehensiveness, right? So the end-to-end understanding, and as Niall said, most of the machine learning books are targeting at the data scientists, and we wanted to actually take the opposite way, which is like targeting everybody else, and also like include the data science aspect of it, a bit of it, because we have built products at scale at companies like Google and Apple and all of that stuff, and what we have learned is more than the technical skills and the data science and like engineering skills and all, like what is the most important thing is the collaboration aspect of it and understanding who is responsible for what, and when need to reach out to whom is all like it's super confusing and super disconnected in a way, and that pretty much defines the efficiencies of product building, especially with like machine learning, because it's a science and you need to marry that with engineering. So that's pretty much like what our thought process, and you see that in the life cycle, and rest of the book is all about the talking about the entire life cycle.
Yeah, thank you for the insights. You mentioned end-to-end machine learning data scientists. Do you think everyone interested in the field should be an end-to-end data scientist or machine learning engineer? Like, what is the difference between like the responsibilities of ML engineer, ML ops engineer, and now from the book there's the ML reliability engineer? Yeah, what are the differences? And do you think to be a good data scientist, be a good ML engineer, do you need to have knowledge of all the fields?
I think so. I mean, people should have the end-to-end knowledge, especially when you are growing in your career, right? When you start, you want to be an expert in your specific area or a topic that you're really passionate about or you studied about, right? But then as the days progress, people wants to learn and people wants to grow in their careers, right? Like different levels, different responsibilities and stuff like that. Probably like Cathy can chime in from the organizational side of things, but in practicality, like people need to understand the full picture, and it's pretty important. I think the fundamental difference between a data scientist and a data engineer and a reliability engineer is pretty much their respective functions in terms of like model building and model serving and like data exchange, and also like making sure the systems are healthy and up and running and there's no customer interruption from the health of the systems point of view. That's where the SRE side of the equation comes in.
I was going to add to that I think it's okay to be specialized. Like there will always be the need to have data scientists who are specialized and who really understand the data and really understand how models work. And there will almost always be the need to have like your operations folks who understand how the systems work and how they scale. And then our thesis in this book is that you need to at least be familiar with the other side. You need to be familiar with not only the product that creates and serves, that trains and serves your models, but also you need to like, even, our thesis was like, even if you're in sales, you might need to know that there is machine learning involved because, what if something really wonky is happening and you need to figure that out and you're like, okay, oh, we actually need to go all the way back to the engineers because of, this training thing that happened and it affected all of the data and now it's affecting our product and it's affecting our sales. And so that's where we are trying to orient a little bit towards, hey, business person, CEO, sales leader, you need to know that ML is affecting your overall pipeline and this is how. But, they're never going to be a specialist in being able to create a model, but they need to understand enough of the magic, right? You can't just shard ML off into the corner and then forget about it.
Yeah, I think just to follow up on the two things that were said there super quickly, the thing that struck me most forcefully in kind of proofreading the totality of the book, right, after having written some of it, I suppose, but not very much, the thing that struck me most forcefully is that it's so hard to be good at ML with the standard organizational technique of I will slice off a bit of the business, give this to a team and dust my hands and walk away. Actually, the requirements for mutual kind of knowledge and interdependence are they're really at a significant additional level compared to standard partitioning of the problem, organizational partitioning approaches. And like that just comes through in everything. I think it particularly comes through super clearly in the incident response stories chapter, actually. And I know you had a great experience reading that, Sophia, but I think the stories in that really do illustrate, actually, like when you pull on this thing, this other thing over here goes tinkle, 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 and actually you don't necessarily expect that. So I think there's a lesson for all organizations and kind of people who are trying to do ML at any kind of layer, really.
Yeah, thank you. I absolutely love the stories in that chapter. I can relate to all of the stories. I feel like I've had similar issues in the past where I have to like fish and search to see exactly where it went wrong. Yeah, I want to give opportunities for Daniel and Jose to ask questions. Do you have questions?
Actually, yeah, Daniel, you can go.
Yeah, just a comment on this topic about the roles and responsibilities. It's just that I've been reading a book about creating like a data-driven culture in the organization, and the author says that you have data engineers and data analysts and data scientists, but I mean, sometimes you don't have a lot of budget, right? You cannot hire just a single guy to do only that, and you have to assemble your team and make the most of the team that you have. And when you're going to hire a guy, you must know what skills are missing in your team and what skills you're going to look for in another team member. And I think that's the great part of this book. I think this book is kind of super ambitious. It touches like everything, So it's good for leaders. It's good for, I don't know, for data scientists that want to understand more about ML ops. So yeah, that's what I like most, I still think you guys are kind of crazy to put on a book like that. I mean, it's too much information. It's very ambitious. You talk about ML and ML ops and how to hire a team and how to organize the structure of like a team topology. But yeah, it's very nice to read about everything, because at least in my position, I think it will be very helpful to look like broadly, to have a better view of the things, you know. So yeah, that's just my comment about that. I really enjoyed the book, even though it was difficult. I had to stop and research stuff outside from the scope of the book, but it was a very good journey. Thank you.
Yeah, and I guess this is a comment in the same lines. So I'm actually like I don't know how even to say it, but active learner. let's just do that. And I do believe in that philosophy of understanding, you know, not only being specialized in one thing and, you know, put a mask on it and forget about the rest. So I actually have a passion to everybody to try to understand, you know, each other's role and have like cross-team collaboration. So what you were saying, you know, I think it resonates a lot on me, because all the companies that I have been working on, I'm more in the traditional engineer background. So started civil engineer, then aerospace, naval architecture. And I've been working in the aerospace industry, in the oil and gas industry. And that's how it is. It's like I hire you for this particular role, right? And that's what you will be doing. And then in recent years, a lot of these companies have been figuring out like we got to do better, right? We can do better and we can optimize our processes. So a lot of this digital transformation, right, is what they call it, right? And they're infusing pretty much that idea. And I felt that it helped, because at the beginning, while I was there, it was like speaking in different languages, like English and Italian or something, right? And people were trying to talk to each other, right? But it's like, I don't know what you're saying, right? And the process just is delayed and delayed and delayed, right? It's not that, you know, they're not good at it. It's just like you don't have feedback or background or fundamentals from that other role, and that person the same. And even to communicate between the same team and company sometimes was super hard, right? That was just my experience. And when this digital transformation started being kind of like enforced in companies to be more proficient, right? It was pushing the boundaries to do that, like do cross collaboration, go and talk to other people, learn about other stuff. And I felt like people were just like talking to each other really nicely after that, right? And they were learning, having that percentage of, you know, okay, 20% of my time will be just to learn something, right? And they get involved in other stuff, and that's how you keep learning and learning and learning. So it did resonate a lot in my kind of like, I guess, professional career so far. And I definitely agree that you will have your specialty, whatever you prefer to do, right? You'll be really good at it, right? But then you need to have like this kind of a list, fundamental knowledge, right, on the areas that surrounds you to better communication and optimization of processes. So.
Yeah,
I'd be very happy with the. Oh, sorry. After you, Kranti.
Sorry, I just want to add a few more thoughts there. So one of the things you mentioned about the cross-functional collaboration, for my 7 years, you know, tenure at Apple, that is something that that I've seen done very, very well, you know, in terms of the consistency across the products. So without going into too many details, like, you know, Apple being a secret company, but I'll try to give you like sneak peek of it, which is like when we are building some products, some user experiences on one side of the company, automatically, without my manager asks me, without my leader asks me, like every engineer is like, you know, they think the ramifications of like, you know, this change, this experience, how does it, you know, work on an iPhone, an iPad, and a Mac, and a watch, and a CarPlay, and like, you know, HomePod, and Siri, all of that stuff, right? And then the minute that they start asking questions, for example, like, you know, I was building something on Apple Music, and then we know that this is going to be exposed on, you know, via Siri, for example, right? But then we know Siri to work, there is like a lot of machine learning involved, a lot of, you know, natural language processing involved. So that the data needs to be exchanged. But we know Apple cares like privacy and like, you know, security and all of that stuff immensely. I mean, you read in the book also, we have a dedicated chapter for that also, you know, in the concept of, you know, privacy in general, right? But how do we exchange the data? Like, you know, how should I model the data so that, you know, the information is not transferred as is, like keeping those things in mind, like designing the systems, designing the architectures, designing the data pipelines and the protocols and the schemas. It's just it's just, more than the technical, abilities, it's about, awareness of like the impacts across the organization and the impact across the systems, so that like, you are aware of the ramifications, and then you design them correctly, and you collaborate with people correctly. You question things, hey, why are you like, transferring this data from this place to this place? Like, there is a potential privacy issue here. So without like a lot of like scrutiny and like a lot of different people coming in doing audits and all, like when we design them itself, like we are aware of them, right? So that is something that we tried articulating in the book, like, be aware, to Niall's point, like, what are the ramifications of like, your decisions that are being made when you're designing something, when you want to create something, for powering the end customer experiences. Because end of the day, machine learning, engineering, SREs, and all of that stuff is all about like, powering customer experiences, right? So how best you can keep in mind about, every aspect, especially in ML, privacy and bias, and like all of these are very sensitive topics. And like, how do you be mindful about them is something that we tried. Over to you, Niall.
No, I like it. I agree. I mean, I'd be very happy if the book was taken as a implicit or explicit argument for, hey, maybe you should like collaborate a bit more, like kind of talk to other people a bit more. That would be nice. But also, as per my comment in the chat, I think also ML kind of works better if people think like owners. And like, actually, Kranti, part of what you were describing about how people apparently work in an unnamed large organization beginning with A is that they are thinking like owners. They're thinking about the consequences of their actions rather than, okay, I have this scope and I will ignore everything out of that scope. It's an externality. But in fact, end-to-end thinking, which is hugely powerful and underappreciated in the world right now, but like specifically organizations, end-to-end thinking is something that goes hand in hand with thinking like an owner. And I think ML really like encourages is the wrong word, right? Because you can achieve ML in your organization with all kinds of pathological behaviors. Like, this is very clear, but I think it is aligned with kind of end-to-end and ownership and so on.
When you say everyone thinks like an owner, like, but who is actually owning the model? You have the data scientist, you have an ML engineer, like everyone is owning a piece. How do you make it as a whole? Like everyone feel like they all collectively own this thing.
Yeah, I can try to answer that. I think the ownership of the models will still remain with the core, like, data scientists or ML, like, side of the organization. But what we are trying to say is, like, be aware of what goes into the model, like understand, like, don't treat that as a black box in terms of like, I don't know, like, I all care about is like, my REST endpoint takes a JSON and gives a JSON back, and that's it. And you take care of the UI and JavaScript, and I don't care about like how you deal with it. And then, okay, you need this data, I'm going to dump this data into some pipeline, and then like, you do the magic, on your side. So I think the ownership of the model still, for each of the systems, not just the models, right? But each of the systems, it's still within the, your primary responsibility in the company, right? But then when we bring all these pieces together, what we are trying to say is like, hey, be aware of it and don't treat them like black box, and like understand the concepts behind it. So that's why, like, if you are a software engineer reading this book, we tried explaining you, hey, software engineer, like, be aware of these, like, black boxes, per se. No, like, go a little bit more and understand them. Hey, a machine learning engineer, if you're reading this book, understand like how a owner thinks, a business like leader thinks, how a software engineer, a systems engineer thinks, and data scientists, same thing, right? So we tried encouraging that aspect of it, so that like, it's a little bit more broad in a sense, but the still, like, end of the day, like, if something goes wrong, there needs to be a single owner, because too many owners also get, is no owner, right? So people need to own their respective areas and their respective parts of the system, but also be aware of, like, when something goes wrong, you immediately know potentially where this is going wrong, and then work with the people. You don't need to be an expert to go solve that, but be aware of, like, bringing in the right people together and as quickly as possible. Go ahead, Niall.
Just going to say, like, thinking like an owner doesn't mean that you have to own everything you see. It means that you have to be aware of the consequences of your actions and aware that you exist in a larger ecosystem which is affected by your actions. Like, it doesn't, if I interpret your question correctly, so Sophia, you're like, well, if everyone's kind of owning everything, there's going to be chaos and people are going to be jiggling around with the model parameters and so on and so forth. Like, not necessarily, right? There can still be a model owning team, but it takes input from more people and it's aware of its effects on other people and so on and so forth. So a lot of stuff remains the same. But Cathy said something. I don't know if you want to come in on that, Cathy, on your note there. If not,
sorry, I'm cooking lunch. This is the perils of working from home. I think so. We tried to make this organizational chapter very much a not making a single recommendation on how your organization is shaped, but like, if your organization is shaped like this, you might need to do these things. And what you're talking about here is like, how do you introduce culture change within an organization? And so a couple of questions I wrote down there is like, what are you measuring? Like, if you're measuring model launches or like models being completed, and then a product launched separately, then you're going to get what you measure, right? So there's kind of like, how do you change your organization so that the processes that you need in these mindsets, so if a mindset is everybody thinks about the end to end, then how do you actually make sure that people are rewarded for thinking about end to end instead of just rewarded for doing their part of it? And so, like, Kranti's example of said company might be, hey, you, like, before you even take a breath, you need to also go think about these other things and how it's working. So maybe it's introduced into your design docs, a section about how is this, again, going to interoperate with X, Y, and Z other products, or, something like that. So it's, what do you do to make that happen? It's, you change how everyone's being evaluated, how you design things. So you change from start to finish.
That part of the book is really great. At least I think. I mean, you don't have like a right way of doing things. You're gonna have like decisions and options, and each options has like strong points and kind of some deficiencies. But it's very nice the way you put. Okay, if you pick that choice, then you should reward that thing that will kind of is the weakest point of that organizational structure. So if you should reward that, because then you're gonna increase the chance that what you're doing is going to work, and that's very nice. And it's kind of obvious when you talk, but I don't see that implemented often in the industry. You see people rewarding some behaviors that they're not I don't know, pleasant, or they're not good for the company.
Yeah. Ironically, like, a lot of engineers are systems thinkers when it comes to engineering, but to then think about an organization also as a system is really important. And like, that is basically what my whole degree is about. It's like, how do you actually think about, instead of just like me and my team and me and like, how do you actually think about all of this as the system? And like, there's so many levers that you can pull when you have a system, and you go, oh, I do this, and it changes all of these things down the line. Like, we do that as engineers all the time, but like, why do we not do it when it comes to our organizations? And so it's again a mindset shift.
On that note, I actually want to add in there, because I'm really intrigued about all this cultural and companies and things like that, because again, I've been in different industries, and now I'm in the tech, right? So I've been seeing more flexible, more open. But if you go to all this traditional engineering that we used to have, like, it was really hard to push for innovation, if it makes sense. So we were trying to say, you know, and it goes back to the first question, like, do we all should know a little bit of everything? You know, the culture is like, no, right? I hire you for this and you're going to stay in this lane, right? And it was harder to start moving around. Okay, I want to learn a little bit about this and I want to learn a little bit about that, because it was all about, this is your role, this is what you need to do. I hire somebody else to do that. And again, it comes all that communication challenges that we discussed, but in terms of an individual, because I try to do this myself, and it helped a little bit that we were in this movement of, you know, big data and, you know, digital transformation. So kind of, I did have some flags that I can use. Hey, we're doing this, so let's just do it, right? But in my case, it was super challenging as an engineer that is designing offshore platforms to sell pretty much, you know, that we need to use machine learning for something that I thought that will optimize our processes. So it was super uphill, to be honest, as an employee, to try to get that message to my management. It was like, they were like, why? What we do works. So what do we want to do better, you know? So those were the kind of like feedbacks that I was getting. We were like, okay, yeah, but if we do that, you know, we can optimize production, you know, we can, you know, extend the life, so be a little bit more environmental friendly, because we don't have to keep installing these things, you know, in the ocean and stuff like that. So, and those were the routes that I used to sell my point, but it was super hard. And it's like, these big corporations are really hard to steer. So it's like a huge ship, right? So when you make a decision like now, you will see maybe the effects in 5-6 years, and then another movement is already moving, right? And so any recommendations that you, with your, I guess, experience, can tell folks like me when I was in that position, because I will be super curious to hear those thoughts.
Kranti. Sorry, Niall's pointing somewhere in the screen, but I'm in a different place than you are. So it's interesting because when I presented at SRECon, I got a very similar question. It's just like, how do I, as a cog in the wheel or some engineer in the system, actually influence up in order to make these things happen? And I think that's hard, right? Like it's partly you have to. Well, I'll tell you my more sarcastic response is, you have to think about the culture of the company, and is that the type of company that you want to work at? And is a type of company where you can't influence your management the type of place that you want to be long term. And then ultimately you start with small steps. You start with a groundswell. You try to figure out, where can I make this work, and where can I like, you know, thinking about data first, and like, how do we actually implement this, and implement it somewhere small, and show that as a place where this wins, and this really got us, you know, made the impact for the business. And then you show that off, and then you try to introduce it more and more places, and then try to find your sponsor who can be like, ooh, I'm going to promulgate this down as well. I'm going to do some top-down sponsorship of this type of vision. And so, and often it's hard to be an engineer with a big vision, right? Because you're like, oh, if only we did all this stuff, it would make things better. And there's a lot of reasons why it doesn't work. Competition, for internal competition, unconscious competition, for example, organizational change is hard. You know, you need a bunch of different things. So I would, you know, those are 2 nuggets of advice. I'm going to hand off to Kranti.
Yeah, I have, you know, a few thoughts there as well. So I think, you know, being aware of what the change you're trying to bring is super important. Means, like, you know, is it about customer experience change? Is it about engineering change? Is it about, like, you know, the team structural change? Like, you know, and then understanding who is the champion of those aspects, right? Like, you know, in the leadership chain, who cares the most about engineering excellence? Who, you know, cares the most about the customer experience? They're super obsessed about that, you know, those aspects of it. And then you basically, like, you know, gather, as Cathy said, like, you know, some allies along with you, and make sure before even managing up, like, you know, manage the peers, right? Like, means, like, you have to build that trust, and then gather the support that's needed, so that multiple voices like matters, right? So like, so it's not just you alone going and fighting and, trying to manage up, but also like, going with your team or going with your allies who think alike on that aspect, and then like, reaching to the leadership and influence them for decision making. But at the end of the day, as I said, some leaders I have seen, they care about engineering excellence. They care about what is the latency of the system. Like they're just obsessed about the P95s and P99s kind of a thing, right? And some people are really, really obsessed about why is this button blue color? Why is this button not like, green color kind of a thing, right? So you need to really understand what change you're trying to make and what's the idea that you're trying to sell. And then identify whom to reach out, in order for that to make it happen. Because once they are sold on the idea, they'll become your salespeople, and like, they'll become like, your sponsors, as Cathy said, and make it happen.
Super quickly, there's a book called Switch by Chip and Dan Heath, Heath, I think, which talks a lot about cultural change in organizations and has some positive stories that you can use to help yourself stop weeping at night when you're trying to drive large-scale change in a big organization.
Oh, Cathy mentioned there's another book, Measure What Matters. Is that the book about KPI and?
Yes, John Doerr, right?
Yeah, I think I read that one.
Yeah, OKRs. Yeah.
OKR,
very
yeah.
famous
OKR.
one.
Yeah. Sorry to change topic. Anyone else has comment on this topic? I have another question. The book covers a lot of great theories, which I love, and I think it will last forever because theories rarely change, and a lot of good info on best practices. But a lot of people learn from building and coding, right? But in the ML field and ML ops, there are just so many tools. Where do you think people should start learning? Which tools do you recommend people to learn?
You first, Kranti.
Yeah, I think that's a very, very interesting question because there's just so many of them. I think it all depends on what is the problem you're trying to solve, and start there, right? For example, if you're trying to build models, then first of all, understanding like what is a model and like what goes into the model kind of thing. But yeah, I need to start writing the code and start playing with some models that are out there, which are like open source, pre-existing. Like for example, like similarity kind of are you trying to solve similarity problem, or are you kind of trying to solve recommendation engines problems and those kind of things? And then start with the existing models that are available with sample data, and then like start tweaking them. Either you introduce your data into that and see whether that pre-existing model works out of the box. If not, how to tweak it, and so on and so forth. Not necessarily that I don't know specifically, like you'll have to think about specific tool, but I would start with like specific specific problem that that you're trying to solve. But if you have any specific example, maybe I can try to help.
No, my confusion right now is a lot of new grad, like a lot of people want to become ML engineers, right? The traditional education focuses on the model, how to build the model, the mathematics, the theory behind it, but nobody teaches you how to build a system, how to build a system from ground up, create the model APIs until serving to the website, right? That's it. That's the theory this book is focusing on. All the other things, in addition to the model building. So how do you learn how to build an ML system, like ML ops? And ML ops, there are just a lot of tools still, not just ML building, but also ML ops. Yeah, just like wondering if we have advice for people who want to learn more about ML ops. like if you build a recommendation system, you could start from collaborative filtering and build a simple algorithm. Okay, you have this algorithm, but now what? What's next?
Yeah, I think if you are a data scientist and if you don't know how to build a web page, for example, because end of the day you're building, let's say you're building a recommendation engine or recommendation system, either you build an API on top of the model. For that, you need to understand how to build a REST API. So you need to understand what is a web server is, and how to what is a REST endpoint is, kind of a thing, right? So either you have to self-learn or you have to partner with an engineer, maybe or maybe your peer student somewhere in the school who is passionate about engineering side of the things, and then you kind of partner with them, and then bunch of tools cloud computing and environments like GCP or AWS, all of them have free accounts. You can start playing with them. You can register accounts there and start spinning off some instances, and then start end of the day, what I'm trying to say is nothing will replace actually building things end to end and see how to connect the dots. But probably Niall might actually have more ideas on the ML ops side of things.
Yeah, so there's a huge amount of nuance to your question. I mean, I am often to be found saying the word nuance before other words. So I say that word a lot, but there's a huge amount of nuance to your question, Sophia, because what you could mean is, or people who want to know more about ML ops often want to know it in a variety of contexts. They're like, we have nothing. What do I do to get something? Like that's we call it jobs to be done in the product space, like you've a specific thing to do. Or you might have, I'm kind of curious about whether or not what we do right now is a good thing or could be improved easily in some specific way that I have in mind. That's a kind of a separate job to be done. Or it could be, I am starting an ML startup and I want to know what the gaps in the market are and yada, 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 right? So there's a huge amount of context that could be driving that question. I would say that, as we kind of touched on earlier, the situation for people who want to build models is relatively easier. It's like, go to Kaggle and PyTorch or whatever. There's just a huge amount of stuff, and it doesn't matter too much. You won't go too wrong if you pick one framework over another because you're training yourself on the basic ideas of what you have to do in order to build a model. Okay, fine. For ML ops, it's total Wild West. It's like, I don't know, pick that one, I guess. And it's a hugely effervescent space in the startup world as well. There's loads of people doing things. Furthermore, there's also different choices available at the platform level, at the provider level, the Databricks and so on and so forth will all do things as well. That is why in the book, we do not say, use this framework. We specify functional requirements, and you say, the thing that you do should be able to do this stuff over here. Otherwise, it's kind of bad because blah, blah, blah. So I suppose that is unfortunately kind of pushing readers of the book towards doing a lot of stuff themselves, which is not actually necessarily what we want to recommend, because there's obviously huge downsides to everyone doing things themselves. But I think that if you keep the functional requirements in mind as you come across the changing tooling landscape, you'll be able to go, oh, they clearly designed this one with this particular use case in mind, and that's what I want to do, so awesome. Or it's not touching what I need to do at all. So functional is better. But if you're saying, how do I even start to think about ML ops? That in some sense is what the book was supposed to stimulate in people's minds.
I was talking to Sophia about this book being like a senior mentor, and he does not give you anything for free, but he kind of teaches you to think, because maybe we have the wrong conception about ML, like you told. It's just, okay, let's just use some algorithms. Let's just make a model, but it's a lot more than that, right? You have to serve and you have to get data, because without good data, it doesn't matter what your model is, you're not going to have good results. And you have to monitor and ensure everything is working fine, and that the world is not changing, right? Because everything may be perfect, but the world changed, so your model does not work well anymore. So it's kind of, yeah, it's kind of a senior guy on your side, just pinpointing like, okay, this could go wrong. You should pay attention to that. You should. That's what I like about this book. It does not give anything for free, but it makes you think about what you should know and what you should be concerned about when you are kind of implementing AI and ML. And I'm really grateful for that, because I work with a data engineering team, and we're not serving ML yet. And I was kind of excited. Okay, maybe in a couple of months we can start serving ML. And then I just kind of, I aligned my expectations with the reality, because it's a lot of work. I don't think we're going to be there in a couple of months. Let me just shift my thinking and think about, okay, more time, you know. And yeah, that was what I really liked about the book.
Thank you. Thank you. I think that's great insights. Yeah, and I know Kranti and Cathy shared learning tutorials on Google and Amazon. I will post online later as well. Yeah, I guess that's a great
those
start.
are sorry to jump in there.
Ahead.
So those are pretty much like, anyone can point. It's nothing fancy about them, but like, at least for people who wants to start playing with some tools, like, without too much of researching and stuff, you can at least start there, and then like, keep playing with the basics. Like try to apply your student knowledge into the actual practical examples and like systems, like, okay, how can I do this, like what is an API, and like, so on and so forth. So it's pretty much the playgrounds to begin with. That's all.
Awesome, thank you. I do feel like computer science programs should teach your book along with the tools. That'd be nice in the ideal world. Are you guys considering teaching?
Sure. Well, we wouldn't mind selling thousands of copies every year, September kind of guaranteed. That'd be awesome. But like slightly more accurately, I think academia has always struggled with the idea of how do we present practice and kind of how do we inform practitioners rather than how we teach theory. The previous kind of efforts I've been involved in, I actually taught a course called Managing Software in Production, which was more or less supposed to teach SRE style principles, which people generally reacted to quite well, but it was not viewed as an undergrad kind of thing. And I suppose the difficulty with those, if you're not teaching them at that point and they're an elective master's, then like you might well just learn on the job as well anyway. So anyway.
Yeah, on that note of teaching, I did have a passion to a point to actually go back to academia. But one of the biggest things and challenges that I actually saw was that when I was through my career, right, and when I did my grad school and everything, for my personal learning, it was great when I have, professors that were in industry at a point and then came back to be professors, because they can give me both, right? And they will say, this is the book, right? So you say, this is the theory that we rule by. But, when I was in this, field and this project, this actually happened. So how you guys will solve it? And I was like, oh, I don't know. The book doesn't say that, right? So, introducing this type of books and more like how the industry is moving, what are the typical issues of industry is really helpful, to be honest, for students, right? And I agree with you. I don't know why still a lot of debate how to do this. I know the universities are trying to do seminars and they're inviting, a lot of like folks from different industries to do that because they already know this is a big challenge, right? Because most of the professors typically are fully academics, right? They've never been in industry, the majority of them, right? It's kind of like a mix, take and go. But yeah, I understand what you're saying. So.
It's also not an area which is stabilizing, like it's not converging, like it's still diverging widely. So it's kind of hard to to write the lecture which will now serve you for the next 20 years. Like that is just not going to happen. So
yeah.
So the takeaway is learn on the job, which I totally agree. A lot of skills I am learning is on the job. It's not actually from school. I have one last question. I know we're almost out of time. I have a career question. So all you guys are site reliable engineer or in that org, or were you were in that org at Google. It's very new to me that site reliable engineers are kind of machine learning reliability engineers. Is that normal or is that specific to Google? And for people who want to get into the ML ops world, is SRE a good career path?
I'm not sure we have enough minutes to cover all of this in detail, but I'll try and summarize super quickly. So SRE and ML overlapping. There would be a question mark around what the definition of normal would be anyway, but I'll say for the purposes of this conversation, it's not normal, but it's not just Google. Taking a step back, when you look at organizations today and how they're doing ML, and if there is any kind of commitment to ML ops at all, right? Because sometimes there isn't at all. But when you find people who are working on ML ops, they can have a variety of job titles, from software engineer, model engineer, right? SRE DevOps would be I feel intuitively a large set of people with that kind of title would maybe be working on ML ops style stuff. Probably data scientist and model engineer, or data scientists at least less so. And I don't think you find many kind of system administrators and so on doing that, purely because the complexity and the loop makes it hard to be relevant to all of those portions unless you have holistic understanding of things. But just to take a step back, the reason why it is useful to think about the set of problems you have in ML ops with an SRE lens is because the SRE lens is about thinking about problems in the distributed systems context and what does it mean for something to be up anyway, and what kind of measurement techniques are best, and like a whole bunch of a body of knowledge about how to think about the question of systems inside an organization. And it turns out that when you take those habits of mind and kind of intellectual toolbox for analyzing other problems, it fits quite nicely onto the ML problem space. And like, oh, actually, maybe that's like a good thing. And you can take that body of knowledge and those ways of understanding the world and apply them to this case with some good results. Like that's hopefully the thesis of the book as well.
Love it. So it's more of a mindset change. I do love all the discussions on the reliability side of things. It has never been discussed in other books that I have read, so I really appreciate that.
Cool.
Yeah, thank you. Thank you so much.
Wonderful. Thank you, Sophia, and thank you, Jose and Daniel. Appreciate it very much.